Okay, it seems like we are live and our attendees are joining us. Let's give everyone about a minute or so and then we can get started. I see some familiar names. Okay, so let's get started. Hello, everyone, and welcome. I'm Sheila Balarinejad, President of the Women in AI and Robotics, the first association in Germany committed to addressing the gender disparity in AI and robotics. As part of our fast-growing organization's activities, we like to introduce role models in our local and global communities to motivate and encourage women to enter this field and envision themselves in such great company. We like to demonstrate that it is cool to be a woman and a geek. I would like to extend a personal thank you to NASA JPL, University of Bremen, DFKI, and University of Oviedo for their encouragement and support in planning and organizing this event. We are super excited to have Sandra, Mihaela, and Maria here with us today. Maria is originally from Spain and holds 2 degrees in maths and physics. She's a research engineer focused on NLP and explainable AI, currently working in Berlin. Without much ado, I will pass on the baton to Maria, who is the moderator and the host of the evening. Thank you, Maria. On to you.
Thank you very much for this warm introduction, Sheila. Hello, everybody. I hope you're as excited as I am about today's interview. We have here with us 2 young women with very promising careers in space robotics. Let me introduce you to Sandra Hernandez, a systems engineer at NASA's Jet Propulsion Laboratory, and Mihaela Popescu, currently pursuing her PhD in space robotics at the University of Bremen and working at a project of the German Research Center of Artificial Intelligence. Welcome, Sandra and Mihaela.
Hi, hello everybody.
Hi, thank you for having us.
Thank you for being here. To start, why don't you tell us more about what you're currently working on? We're going to share a screen to show the audience the cool pictures you have sent us. And this way we can all imagine the robots you're working with when you talk about them. So, Sandra, could you tell us what exactly is a systems engineer and what do you do in your day-to-day activities?
Sure. I would say a systems engineer is kind of like a buzzword for many types of engineering. I specifically work on M2020, but I work on the test bed. And what we do is that we test a lot of hardware and a lot of software, and we take care of integrating a lot of instruments into the test bed. So the test bed is a set of hardware and software and simulation. Like this one you see on the picture, this is what we call optimism. And this is a test bed that's very, close to perseverance. And so I work on that, making sure that everything works well and just checking for activities and just making sure everything works well. I work mostly with a robotic arm, so performing a lot of first-time activities, validation and verification with a robotic arm and instruments. Yeah, that's what you see right there. So an example of an activity that I do is we try to drill horizontally. Usually we would attack it vertically, but we just wanted to try out drilling horizontally. in the end, right there where you see the two sticks, or if you could go back to the previous one, please, where you see like the two sticks, those are called stabilizers. And in the middle, there's a drill right at the end of the robotic arm. And so we want to see different orientations of how we can drill. So that's just an example of what I do on one day. Every day is different. So.
Well, that really sounds exciting. So first, before continuing, I would like to make sure everybody in the audience knows what we're talking about. So I would like to say that Perseverance is the rover searching for signs of ancient microbial life on Mars. And the objective of the Mars 2020 Perseverance rover mission is to explore the past habitability of Mars and also help pave the way for future human exploration of Mars. Is that right?
Yeah.
Okay.
Yeah. Yeah. We also, sorry to interrupt you, we also perform flight on a rotorcraft for the first time. So we do a lot of cool stuff with Perseverance.
That sounds really cool. Yeah. So you work with Optimism, and as far as I understand, Optimism is kind of a twin of Perseverance, but on Earth. And yeah, I would like to know if you could explain us why Perseverance actually needs a twin here on Earth.
Sure. As you can imagine, it is difficult to send a mechanic to Mars. So we would like to have a twin here on Earth. So that way, if there is an issue with Perseverance, we can replicate the issue on Optimism and sort of troubleshoot from there. It's really just replicating the issue, seeing what solutions we can come up with to solve that issue, and then implementing the correct solution into Perseverance. So that's pretty much why.
Okay, yeah, makes sense. I guess you really have to think twice before sending somebody to Mars. What about you, Mihaela? Could you tell us about your project at the University of Bremen and the DFKI?
Hi, thank you, Maria. Thank you, Sandra, as well. It's very interesting, your work, and I'm very glad to be here with you. I must say that I find the link between robotics and space research very interesting. And now let me tell you a few words about the project I currently work for at the University of Bremen and the German Research Center for Artificial Intelligence. The main goal of this project is to employ robotics, namely here you can see humanoid and exoskeletons, to help the astronauts set up camps on the moon or Mars or any other planets as we envision future manned missions to other planets. So they are basically interacting with the astronauts. And also about my PhD, I can tell you a few ideas on the next slide. I research on localization of mobile robots, like this humanoid in the picture or other legged robots, but actually mobile robots are very versatile and have lots of applications. Currently, for example, a lot of self-driving cars and autonomous drones, they are all able to autonomously navigate in the environment. And however, in order to reach any goal, these robots, they first have to know where they are located. So let's make it easier to understand. Similar to us humans, let's say we go to Paris and we want to visit the Eiffel Tower. We first look at the map, see where we are, then we plan the route and reach there. This is what happens with the robots as well. They need localization. And I focus on humanoid robot localization since there are a lot of challenges to solve. Biped robots are hard to control and it's hard to maintain balance while walking. So localization plays an important role to estimate as accurately as possible the position and orientation of the robot center of mass and keep the body upright while moving, like running or walking or any other actions.
Whoa, okay, that really sounds like an interesting challenge to tackle, to be honest. Thank you very much both for sharing with us the insights about what you're currently working on. Really, both projects sound amazing. I would also like to know how you got started in robotics and how was your path till you landed your current positions. So why don't we start this time with you, Mihaela? Like, what inspired you to become an engineer, and yeah, what motivates you about working in this field?
Thank you. I like this question. I've actually always been fascinated by science and technology as a child and young teenager. And I find nature really amazing, and there are a lot of mysteries there to discover and unravel. But I was even more fascinated by technology since it is man-made, and this emerges completely out of human intelligence. It is amazing to see what human brain can create. So in school, I was good at maths. I discovered programming, and I started to enjoy physics and learn how the laws of motion work. So I think it was a natural path for me to head towards robotics, since robotics actually encapsulates knowledge from all these fields and even much more. So I'm glad to work in robotics and AI because they have the potential to improve the quality of life and even enable people to enjoy better life. For example, now hard labor tasks, they can now be taken by robots, and people that are missing limbs or are handicapped can get the chance to walk again with intelligent prostheses. And this is a huge advancement. That's what makes me proud to work in robotics.
Wow, yeah, so inspiring. Yeah, I think I might drop NLP and explainable AI even and start working in robotics. And what about you, Sandra? What inspired you to become an engineer?
What inspired me to become an engineer? So when I was 17 and I started driving, my dad passed on his 1999 Mazda Miata for me to use as a car. And after a few months of driving, I was driving it everywhere, to work, to school. It started to give me some issues, and I didn't really have the time to leave it in a mechanic. So I was really encouraged to sort of find out and figure out how to fix it myself. And with the help of my friends, I learned to temporarily fix it. And yeah, I think the thing that I loved about this experience was that I learned to see things as a system, how components work together. And that was when I decided that mechanical engineering was for me. I've never been so grateful to receive such a faulty gift. And as a woman, I was raised, or at least encouraged, not to get my hands dirty, or that motors and machines were too complex for me to understand. And my father was the one that really encouraged me to find solutions to my own problems. And engineer or not, I was responsible for it. So it was really a logical decision to go into engineering.
Well, yeah, great. Well then, actually, like no one should be constrained by the gender to choose what they do. So sounds pretty cool. I actually know that you wanted to become a vet. So when did you decide to move into engineering?
I wanted to become a vet. I've always loved animals, but I decided that, it would be a little too sad to see animals suffer every single day. So when I started to study, I decided that I really loved math and science. And with this experience of this Mazda Miata, the car, that's when I decided. And yeah, I didn't even look back at my decision of not being a vet.
Cool. What about you, Mihaela? Did you always wanted to be a vet? Oh, sorry, an engineer.
Well, I never wanted to be a vet, but also not an engineer since childhood. I actually also had other dreams. I will tell you. After I graduated from the military high school in Romania, I wanted to become a jet fighter pilot in the Romanian army. And although it didn't work out for me at that time, I still enjoyed a lot of flying with smaller aircraft such as gliders and motorized hang gliders and some other small aircrafts, piloting myself.
Well, yeah, unexpected. Do you still fly? And yeah, maybe would you like to combine this passion of flying with your actual expertise in robotics?
Well, currently I don't fly that much anymore. I think the priorities switched and I don't have so much time, but I would definitely like to apply my knowledge in robotics for flying and other space applications in the future. It's very interesting.
Okay, thanks. And what about your studies? I know you interned at the University of Bremen and then went to TU Dortmund for your master's. So would you like to tell us a little bit more about this, this stage as a student?
Yes, I think international experience is very important. And in my case, I had my first international experience at the University of Bremen in Germany during my bachelor's. This was the time I actually first got in touch with robotics, and I wanted to continue my studies in this direction in Germany. And it wasn't easy. The first step was to look for a scholarship to finance my studies. And I simultaneously applied for a robotics master's program in English because my German skills were not great at that time. And actually it turned out to me that the best choice is the Technical University of Dortmund, where I graduated the Automation and Robotics master program last year in 2020.
Nice, congrats. And yeah, I really feel you. German is not an easy language to learn.
Not at all.
What about you, Sandra? You're from Spain, but moved to the US to study. So why did you choose to move there?
Yeah, so my father moved here when I was very young, but I chose to study in the US because I thought, and I still think, that this country offers you an environment in which growth is very encouraged regardless of your born attributes. I was only supposed to be here for a year for high school, but during that year I thrived and I was the best version of myself, and I realized that Spain was just not for me. So
okay, and do you maybe plan on going back to Spain at some point?
No, no, I don't think I will be going back to Spain. I'm not against going back to Europe, but I don't think Spain is in my cards. But I know that you're from Spain, Maria. Are you thinking of going back or?
So I finished my studies last year. I studied in the north in the University of Oviedo, maths and physics, and then I moved on January this year to Berlin to join a startup as a research engineering. And now I focus on explainable AI and robustness and NLP, and everything is really interesting, and I'm very happy here. So I'm not sure when I'm going to go back. But I'm definitely concerned with some differences between English and Spanish, for example, when it comes to research, for example, in NLP. And I did found a community of Spanish-speaking NLP professionals to advance the development of NLP in Spanish. So I'm not sure if I'm going to go back soon, but at least I'm trying to, do something for Spanish or Spanish-speaking people. So but let's see.
That's awesome.
Thanks. Let's get back to your path. So how did you end up where you are right now? Mihaela, how did you find out about automation?
Yeah, very good question, because it's not very popular. Automation was a choice of studies in my university in Romania, the Technical University of Cluj-Napoca. It was very close to the computer science department, and that was very popular at that time and still popular. But I was more excited about projects and systems that allow me to have some hands-on work, not only computer programming. And this applied part drew my attention actually to automation and later on to robotics now.
Interesting path. What about you, Sandra? I know you did some internships before landing at NASA GPL. So what kind of projects did you work with, and how did that help to get your current job?
Yeah, in engineering, internships are very important. I can't speak to other countries, but at least in the US, it's one of the most important things to have in your resume as an engineer. I had quite a few. I had an internship with Boeing at Kennedy Space Center, aiding in design with the SLS rocket. I also did controls in Honeywell with a fighter jet, and which, sort of developed my software skills. And then I think the most important that internship that relates most to what I'm doing right now at JPL is when I did electrical test and integration for Boeing, working on satellites. So yeah, those were the internships. And like I said, I think that test and integration internship was the most important.
Okay, and more exactly, I think this is actually a question that a lot of people here would like to know the answer to. So how did you actually enter NASA JPL? Big question.
Yeah, that's a very popular question. And honestly, you're probably expecting me to let you in on a little secret or to tell you something that you don't know, or but it's pretty boring. As with mostly everything, it happened with a lot of hard work and a little bit of luck. During university, I was very motivated to work in the aerospace industry, and it had been my dream, understandably so, I guess, to work for NASA, or specifically JPL. I excelled in schoolwork and diversified my resume, trying out different projects and trying to expand my skill set. And I did as many internships as I could so that I could get relevant job experience. Like I said, internships are super important. I'm sure I don't have to explain to you how many hours of studying and you have to put into, especially for these technical degrees. So it was a lot of hard work. And that was pretty much it, just a little bit of work, just a little bit of luck. I had been lucky that my internship was electrical integration and test, and that is like exactly what I'm doing at my current job. So that's pretty much it. Lots of hard work, I'm sorry to say.
No, don't be sorry. I mean, yeah, who would say hard work is the way to get into NASA,
Yeah.
that's JPL, right? So yeah, thank you very much for your not little secret, but for confirming also that hard work is actually the way to go. Yeah, let me now ask you a couple of maybe more technical questions. So the first one, I think maybe for you, Sandra. You talk about rock drilling at the beginning of in the first question. So how do you determine which rocks to drill into?
Sure, that's a great question. And I love that question. My area of expertise is mostly drilling, not deciding which rocks to drill on. But we have this really cool instrument. There's this camera on the rover called SuperCam. And I don't know if you guys saw, but there's a mast and like on top of the rover, and there's a camera which shoots a laser and vaporizes the target. In this case would be rocks. And it is through imaging, it is able to tell sort of like the chemical composition of the rock. And then therefore we determine if that is a good candidate to drill into. Obviously, we don't want to drill into rocks willy-nilly. We want to be sure that, we want to drill into that specific rock. But yeah, it's because of SuperCam, which is really cool.
Cool, thanks. And for you, Mihaela, since you work with robots and also humanoid robots, could you tell us how can humans interact with robots?
Sure, I'd be glad to. Actually, I'm also fascinated by this topic, and there is very interesting work in my team that focuses on using machine learning for human-robot interaction. So namely, the human provides feedback to the robot only by the power of thought, so to speak. We measure brain activity as electrical signals. And so the whole process works like this. The human wears a cap with electrodes on the head. These electrodes measure the EEG signal. And meanwhile, the robot is performing some, let's say, simple task like pick and place. And if the robot action is wrong, if the pick and place task is wrong, then our brain, when we see the wrong action, automatically generates a so-called error potential signal without even us noticing it. It's not a conscious decision that we say, oh, this motion was wrong, but it's generated very fast in our brain. And this signal is analyzed using neural networks. And then it is used as a feedback for the robot to improve itself and its actions. And it's amazing that we can communicate that closely with robots. And yeah, maybe this technology will turn better and read our intentions later.
Well, Yeah, very interesting. To be honest, listening to you talk about this, yeah, technical issues like so incredibly complicated, we can see that you both have come a long way since you broke into engineering, and I'm pretty sure it wasn't always easy. So would you like to share with us some of the challenges you might have faced? For example, Sandra, what challenges have you faced, and how did you overcome them?
Sure. The greatest challenge I would say is stress and time management. So I was working full time to pay for my studies. And so that definitely helped me develop a lot of time management skills. I would also say that being in a male dominant field, I received a lot of judgment for studying engineering, but I would have to say that was mostly, in my experience, by women. And I also received some resistance in previous companies to, implement new ideas or plans. But this is unclear to me if it's because of my expertise or not expertise, or because of my gender. But yeah, I would say stress and time management is the biggest and ongoing obstacle. Working with tight deadlines for school or either project can be very stressful and requires to allocate exactly the time you need for those activities. So yeah, I would say those. Yeah.
Okay, what about you, Mihaela?
Sandra, I can completely agree with you on this. Yeah, time management, stress, finances, I can relate to all these problems. I learned how to deal with all this by experience, and as the quote says, what doesn't kill you makes you stronger. However, I also try to listen to my body and get enough rest and exercise, so I'm able to keep going on the long run and not run into burnout.
Yeah, stress, time management, burnout. I think, this sounds familiar to a lot of our attendees and people working in our field. But anyway, we all agree that pursuing a career in this field can be challenging, but it also has a lot of advantages, right? So I would like to know, how has your engineering background helped in your non-professional life? For example, for problem solving or something similar. Mihaela, would you like to go first?
Sure. Yeah, that's true. In my daily work life, I constantly face challenges and problems that I initially have no idea how to solve. But with perseverance, maybe Sandra would also like this word, perseverance, it always works out in the end. And I would say I learned how to cope with uncertainty, and I learned how to trust my abilities in various situations. I think having an engineering background gives me a boost of confidence when I need it.
Nice. Happy to see to know that. What about you, Sandra? How has your engineering background helped you in your life?
Yeah, I would say that the technical side of engineering comes secondary to the degree. Learning all the formulas, terminology, Greek letters is something that is very useful for industry. But my main takeaway in engineering was learning how to solve problems. During school, you're assigned many, many problems, but it is up to you to look at all the variables and come up with a solution which will take the least time, or, come up with a good solution. I would say in our day-to-day life, we face many problems or challenges. They don't need to have a negative connotation. And we constantly have to find solutions and alternatives considering all the variables. Engineering is just that. In life, we deal with budgeting, for example, and in engineering, we deal with currents and volumetric flow rate. So definitely a lot of problem-solving skills.
Yeah, I couldn't agree more. Yeah, so we're all in the beginning of our professional careers, but since you're already like so far and with such a great future in front of you, I'm sure you have already experienced a lot, and I would like to know, what was the most rewarding moment in your career so far? Mihaela?
Well, I had many rewarding moments at every stage in my professional life, and I think we should all celebrate every small or big success that we achieve, not just the most important ones. And just to name one, it was the moment I was awarded a scholarship to start my master's in Germany, because It was a huge step in my life to start a new chapter alone in a foreign country. And all this was possible only due to my hard work and good results. So in the end, it's the amount of work that we put into something which makes it valuable and rewarding for ourselves.
I'm going to say that quote. What a great vision to live according to. And what about you, Sandra? What was the most rewarding moment in your career?
Oh, the most rewarding moment in my career, without a doubt, was when Perseverance landed on Mars. It was definitely a moment I will remember for the rest of my life and that I will take a lot of pride in.
Well, and yeah, curiosity, did you watch it with other colleagues from NASA?
Yeah, so we watched it in the Mars Yard. I showed a few pictures of that earlier. It's actually, it's called the Mars Yard, and it's a little piece of Mars here in Pasadena, California. And it's actually where Optimism lives. We love to use this location for driving and trying out different features, but we watched it, the whole team, most of the testbed team, and it was definitely a moment to remember.
I think I need to say that I'm very jealous to know this. Yeah, so what about the future? Sandra, do you have any ideas of what you want to do in a couple of years, maybe?
Yeah, so I don't plan too far in advance. I like to plan as I go. So I know for right now, I would like to continue on testbed. I love what I'm doing. Maybe move into operations. The operators are the group of engineers who assess the data and send commands, basically plan the activities for Perseverance and Mars. So something very different to what I'm used to. But I would also like to go to grad school relatively soon.
Okay, interesting. To grad school, what would you like to study?
Yeah, I would like to deepen my knowledge in robotics. I'm still undecided on whether I should do a master's and PhD, but I know it definitely has to do with robotics.
Nice. And Mihaela, you're already with your PhD. So what do you have in mind for when you finish it?
Yes, I've actually always planned for short time spans from one challenge to another, so to speak. Now I'm doing my PhD, and I envision some ways that society and also the robotics community could benefit from it. I left Romania for my master's studies and now for my PhD, but I would like to reestablish some kind of link later on with the robotics research in my home country. And this way I could give back to the community that raised me and also offer other motivated people the chance to enter this exciting robotics community.
So exciting and inspiring. I hope you can make this dream a reality.
Thank you.
So yeah, Sandra, Mihaela, you're both engineers. You have both great and promising careers in space robotics, and you're both women. So yeah, I would like to know what's your experience being a woman in this industry. Sandra, would you like to start?
Sure. In the beginning, when I was first studying engineering, I faced obstacles from other non-STEM women, which is why I think women empowering women is the first step in closing the gap. And then obviously, I think I've had to defend my ideas more than my male counterparts, but this could have also been due to my inexperience.
Yeah, I could.
Sorry. Yeah, you can go.
Yes, I could say my experience was mostly very good, and I encourage women to enter the robotics field. It's true that sometimes it might take a bit longer, maybe to gain the male colleagues' trust in the technical abilities, but I think it's also a matter of mindset. So if we walk with confidence into a meeting, our voice will definitely be better heard. And I think especially at the start of our career, it is important to dare to speak up for ourselves.
Such a nice advice. Yeah, and I definitely agree with what Sandra and also you a little bit like we're talking about. Like, I really think that women empowering women is very, very important. So yeah, how do you actually understand the need to give women a voice in the STEAM fields, maybe compared to other non-tech fields, Sandra?
Yeah, going back to what you said, I think women empowering women is the first step. I think that is very important. But to answer your question, I think there is a stigma that STEM fields are mostly men, or at least those were the type of comments I would receive when I would tell someone what my major was. And we need to learn not to limit ourselves, and much less have other people limit us. Women are needed just as much as men in any field, and we need to bridge the gap to allow for a more diverse environment. Not do we need more women, but we also need more diversity in terms of race and ethnicity, life experiences in general. And this is how ideas originate, by having people with very diverse experience coming together and troubleshooting.
Yeah, I totally agree with Sandra here. I'd also like to add the fact that we need more role models in STEM, so that girls grow up in an environment where women naturally fit into this field and not be biased towards specific areas or careers.
Yeah, totally agree. We really need more role models. So do you actually have any role models, Mihaela?
Yes, I like to find role models close to me among the women I interact with. One of them is my current team leader, Dr. and soon-to-be Professor Elsa Kirchner, who successfully built up a research career in robotics and brain research. And this alongside with a beautiful family with 2 children. And I find this combination between career and family particularly inspiring and impressive.
So nice. Yeah, and it's also really cool that you know her personally and you can speak with her and get some advice from her. So yeah, happy. What about you, Sandra? Do you have any female role models?
Yeah, I definitely do. And similarly to Mihaela, I don't think I could have any role models who I don't know personally. And my role model is Diana Trujillo, who is also on the M2020 mission. And it is because I can relate with her upbringing and her stories that she has shared publicly. And I totally admire her trajectory.
So nice that you both know personally your role models. I guess you get a lot of advices from them, and I would like to ask you if you could give some advice also to young girls that are interested in joining the STEAM fields. Sandra?
Yeah, I would say do what you love, whether that is STEM or not, and don't listen to any negative comments. Also, be open for constructive criticism only when it's constructive, and work really, really hard. Perseverance is key.
Well said, Sandra. I think working hard is something women often do. We seem to be born with it. I would also encourage you to avoid perfectionism and not forget to focus on the positive aspects of your work. This really helps to stay motivated during hard times.
Thank you so much for sharing your advice and your experience and insights with us. And now we're going to take questions from the audience. And the first one is for Mihaela. So it says, hi, Mihaela, great to hear your talk. I'm a robotics engineer and would love to hear the different techniques you use to localize the robot. Do you use LiDARs? I'm sorry if I'm wrong.
Yes, actually, for localization of mobile robots, we can use a large set of sensors. Let's say you can classify them in 2 categories. There are sensors which perceive the world outside, like the environment, and sensors which perceive the robot joints and other characteristics inside of the robot. So let's say proprioceptive sensors perceiving the inside variables, so to speak. and the exteroceptive sensors, the ones perceiving the outside world. And LiDAR is one of the sensors perceiving the world. It's a laser scanner. It sends beams into the environment, and when the beams come back, we can measure the time of flight of the beam, and we know where objects are located or how far they are located. And this is one of the sensors used for localization. But alongside with this, we also rely a lot on camera localization. Now we have very advanced software, standard computer vision, but also machine learning that can produce, let's say, a pose of the robot. They can reconstruct the three-dimensional world environment, and this we can use for robot localization. And to give some example of internal sensors, very common is the inertial measurement unit, IMU, which measures the angular velocities and the linear accelerations of the robot. So it's kind of a motion measurement device. Yes, and actually, because we have so many sensors we can perform localization with, we try to use as many as possible and then fuse the data, perform some sensor fusion to get the most accurate estimation.
Whoa, that was really a masterclass on how to localize a robot. Thank you very much, Mihaela. Thank you. The next question would be, to what degree has your point of view changed since transitioning from practice to work? Would you like to take this one, Sandra?
Can you repeat the question?
Yes, sure. To what degree has your point of view changed since transitioning from practice to work? So what's the difference between theory and practice in robotics?
Oh, I would say, at least in my project, I would say a lot of the theory is implemented, but a lot of obviously all of the theory is implemented, but we have a lot of processes to sort of make it easier and go faster. So I would say from theory to seeing it in practice, visualization is like super much easier. But I don't personally deal with as much as the theory anymore. It's more of like the development side. I hope that answered your question.
Sure, maybe Mihaela, you want to also add something to this? So the difference, yeah.
Yes, I think actually both are important in robotics, or at least in my current work as a PhD student, because we always try to develop new theoretical methods, which require a lot of mathematics and deep thinking, but we also try to implement them on the real systems and the real robots. So there is a lot of practice involved as well. And we learned that things that work in theory don't work in practice. And we need a lot of perseverance again to succeed.
Yeah, perseverance is the word of the day. So the next question is, what is your opinion towards failure cases? What did you learn from unsuccessful projects? Who would like to take this question?
I can say a few words. I think, it's difficult to define failure. Maybe you have a deadline and you want to complete some project by that time, and if it doesn't work, it feels like a failure. But sometimes tasks are very complex, and you cannot expect that it will work from the first try, or maybe you need more time than expected. So you can also reframe failure as maybe not done yet, but there might always be a chance that it will work in the future.
Nice, so positive.
Yeah, and I think I would like to add something. When we are testing, I think failure is just, or even more as important as successes, because that really lets you understand what the capabilities of the system or whatever are, right? So where your limits are. So I guess you learn more with failures than I guess with successes.
True, makes sense. Yeah, thanks. Have you ever been confronted with a prejudice about women working in STEM? And I would like to also add in non-STEM, because before, Sandra, you were saying that actually you've been like, you've felt like more judged by women that weren't working in STEM related fields. So yeah, just an open question. If you have ever been confronted with a prejudice about women. Like from women, sorry.
From women, about women?
Yeah.
Yes, all the time. Especially when I didn't have my degree yet and I was not working for NASA. A lot of women would oftentimes question my decision or my path because it is a male-dominant field, and they were, questioning my capabilities as a woman. Hopefully, through my experiences, I have been able to prove them wrong, which is why I think women empowering women is really the first step in closing the gap. So yes, all the time. And I guess, but a follow-up question or like something I would like to add also, what would you do to avoid it? And my best response is ignore it and prove them wrong.
Nice. Yeah, totally agree. So the next question would be, if you could change one thing about working in robotics, what would it be and how would you change it? Do you want to take it, maybe, Mihaela?
I'm thinking actually now, since I'm at the beginning of my career in robotics, I'm excited to be able to work with robots. So I didn't think so far about things that I want to change. Maybe I think this comes with time, to have to somehow to speak the robot's language and be able to communicate easier, like to remove these difficulties in programming and fixing all the bugs and communication issues, and just have an easier interface with the robotic system, I think.
Cool, thanks. This is a question from both from the audience. What programming language do you think might be better for robotics, and what characteristics should a robotic engineer have? Can anyone do this, or does he need or she need talent and intelligence?
I can begin. I now use Python, but we don't do a lot of programming. In my previous internship with controls, I did use C++. But I guess once you know one language, the other one comes by easy. So I wouldn't put too much weight on learning one specific language. Just because of robotics, I would say learn one, and if you need another one, then you can always learn it. And I'm sorry, what was the second part? If they need a special...
Yes, if anybody can do this, or you need a special talent or like more intelligence.
No, absolutely not. You don't need... The only thing, like I said, I mean, I feel like I sound like a broken record, but the only thing you really need to be successful and to be successful is to work hard. You're not born good in robotics. Like, you're not inherently good at it, or programming or math and science. It all comes through sitting down and studying. So I would say anyone can do it as long as you have the willpower and the discipline to sit down and study.
So perseverance again. What would be your opinion here, Mihaela? What programming language do you use?
Yeah, very nice. Now I work closer to robot control, and as Sandra said, for this, C++ is more important. And for testing some systems, I use Python. And parallel to this, there are some other low-level programming languages, but as soon as you get the grasp of it, how it works, mostly you can transfer the skills from one programming language to another. And yes, I think I never studied with the purpose of becoming a roboticist. I was just interested in technology and in these subjects like physics and maths and programming. But I think being a roboticist, it's very specific, and somehow you need knowledge from many fields, and it's more, let's say you figure it out later when you like all these topics.
Perfect. We have another question. We have a lot of questions. It says, Sandra spoke about robotics and how it was about finding solutions or solutions that work the most efficiently. Which specific problems in your project were something that required the most effort or were the hardest to find a solution for? So I guess this is for Sandra.
That required the most effort.
Yeah, the hardest one.
It's difficult to respond to this question because every day we have different problems, different obstacles. I cannot recall one specific one that was insanely difficult. I think they're all equal in difficulty. I'm sorry, I cannot think of an example.
That's okay. There's a lot of different stuff. So yeah. Would you have an example, Mihaela, maybe? Or
I was thinking every project seems difficult at the time, and after you do it, it's easy. So it's difficult to rate them in the past.
Okay, yeah, fair enough. So Mihaela, this next question is for you. And they want to ask, what type of aircraft will you get the license for next? G5? Don't know what a G5 is.
Well, actually, so far I've flown with motorized and unmotorized aircrafts, but just with small ones, with maximum 2 seats capacity. And later, I don't know if I continue this as a hobby, then also with smaller aircrafts. And for professional career, then of course larger ones.
Okay, interesting. So after becoming familiar with this environment, I think they mean with the robotics environment, space robotics environment, do you suggest this occupation to other women? And if yes, why?
Please.
Sorry, go ahead.
You can answer both.
If I suggest this occupation to other women?
Yeah.
Yes, as I would suggest it to any men. We need more people in it, and I encourage women just as much as I encourage men. Why? Because if it interests you, then it's the right path for you. Very interesting, a lot of future here, and it's really, we do really cool stuff.
Yeah, I totally agree on that. It's very interesting, so and exciting. That's why I would recommend it to anybody as well.
Perfect. Yeah, I think I'm really going to consider it. This one is again about challenges. So how do you motivate yourself in case of failure or a difficult circumstance?
So this is when the self-discipline comes in. You need a lot of self-discipline to study this difficult and challenging degree. So whenever there's challenges or you're going through a rough time, you need to push yourself somehow. What helps me personally, which is why I love working on the testbed, is that when there are issues and you need to find a solution for them and you're really, you cannot seem to find a way out or find a viable path, what is the most rewarding is just seeing that at some point your solution will be implemented and you will be able to see it visually. So if there's a problem with the robotic arm or something and you think, okay, what can be the issue? What can be the solution? And you implement it, then it does what it's supposed to be doing once you implement it. So I find that is very motivating for me to actually see it happening.
Yeah, then seeing the results of your work is always very motivating. And I guess with robots, it's kind of easier than if you train a neural network in my case, you know. So,
Oh yeah.
What about you, Mihaela? How do you motivate yourself?
I think maybe it comes from my nature that I like to push forward and make things work. And I look in my past experience and I see that I achieved already so much, and that the small obstacle in front of me, maybe it's smaller than I think. Yeah, I try to put this in the big picture and remember all the small successes I had in the past, or other robots that worked previously. And definitely when working with hardware is a very satisfying feeling to see it move and work as you programmed it.
Can imagine. So I think this is our last question. It's for Mihaela, and it says, "Hi, Mihaela, I'm also a student in the robotics course at TU Dortmund. Very glad to hear from you. Can you share which subjects or skills helped you the most in this field, since robotics is such a vast field?"
Oh, nice to hear from you as well. Actually, as a student, I was also a little bit disoriented to find my path in robotics because it's a very large field. And now, because I focus more on mobile robotics and I find this interesting, I would suggest the classes on, of course, mobile robotics and machine learning, because this is going to be embedded in a lot of systems. And also what I find very useful is statistics, because nowadays we work with a lot of uncertainty in our data and we have to deal with this perception, like computer vision and other fields that makes you passionate about.
Cool, thanks. Actually, we have another question that comes from YouTube, and they want to know, how useful do you think a PhD is? So I guess, Mihaela, you think it's useful because you're actually doing a PhD right now. But I would also like to know afterwards, the opinion of Sandra, because you said that you were maybe going to do a master's or a PhD. So yeah, what do you think?
Well, yes, obviously, as I said, I think it's useful. That's why I started. And first of all, I think it's useful for myself and for my own development to get this research capabilities to analyze problems in depth and find solutions for it. So this would just, let's say, increase my ability of problem solving in a scientific way, let's say. And I also enjoy theoretical work and mathematics. Well, from the job perspective, let's say in Germany, maybe PhD is appreciated in robotics, although not necessary or mandatory. So I would say this is a matter of preference or choice.
What about you, Sandra?
Yeah, so working in industry right now, what I'm doing, master's or PhD is not needed. It's a nice to have, but seeing a PhD is a bit of more of a time and monetary and investment, then I would say a master's. For what I'm doing right now, I don't think it is super useful. A PhD might be more useful for research or some very specific topics regarding missions, but in my field, not super necessary. Even a master's, it's more about personal preference and sort of where you want, what direction. You can use that to sort of define what direction you want to take your career in.
Okay, thank you very much, both of you, for sharing your experience and your insights with us. And before concluding this event, I would like to thank Sheila, the president of Women in AI and Robotics, for her support and for always being there for us. I would also like to thank the production team, Christina and Sania, for helping with the promotion and organization of the event, as well as Hargabi for helping with the technical setup. And once again, big thank you to NASA GPL, the University of Bremen, DFKI, and University of Oviedo for their support in planning and organizing this event. And of course, thank you, all the attendees. I hope you enjoyed this event as much as I did, and I'm really looking forward to seeing you soon.
Thank you very much. It was a great event.
Thank you, everybody.